The catalog component plays a critical role in the distributed digital twin of the SRADI concept, and here we shall demonstrate the key aspects of the catalog. This instance of the SRADI catalog is specifically designed for members of our institute, the Hans Eisenman Forum, which is the World Agricultural Systems Center located at the Weinstephan campus of the Technical University of Munich. To implement the catalog, we use an open source software named CCAN. CCAN is used by many governmental organizations all over the world for their open data platforms. The purpose of this work is to bring together all agricultural related resources of all members of our institute. The same can be done for other use cases, such as for rural areas. One of the advantages of this catalog is to manage organizations and stakeholders. This means that different stakeholders with diverse interests, use cases, and resources can share information through this catalog. At the moment, we have 30 research institutes who are active here. We also have the TUM administration, TUM partners, and other external partners who are using this catalog, collaborating and generating information. This catalog gives each organization the possibility to manage its own resources, users, and access rights. For example, for the Hans Eisenman Forum, we have here a list of members with different roles. The admin user can manage the access rights of the organization, for example. The user with editor role can edit datasets, or there might even be a user who is only allowed to read imported resources. In this demo, we show two features of our catalog. The first is an improved structuring and retrieval of information by using specialized resource types, which is defined in the catalog as groups. In the catalog, we have three categories. The main one is shown here. It includes all 9 resource types shown in the metadata model. These are device, such as GPS sensor, landscape objects, such as a land parcel, method, like the Sanger sequencing, project, online service, like web map service for satellite imagery, dataset, for example, an Excel file, software, such as S3 ArcGIS, online application, like the Grafana web client, and animal. The other two categories are specific to this instance and are met based on the requirements of our institute. These are research stations and research themes. The second feature of the catalog is the linking of information on the basis of common unique physical objects, such as a land parcel. We shall show how this helps in more easily finding relevant information and in understanding relationships between resources. For each resource, we can have either outgoing references, where the owner of the resource can define what other resources it is related to, or incoming references, where owners of other resources can define relationships with this resource. For each of these, regardless of incoming or outgoing, there are 3 types of specialized relationships: depends on, links to, and child of. The depends on relationship shows that a resource has to be seen in the context of another. The links to relationship is for linking resources which can exist independently from each other. And the child of relationship expresses hierarchies, such as the relation between projects and subprojects. Based on these well-defined semantics, the relationship between resources become clear. Here is an example of a land parcel registered as a single entity in the catalog. For example, this land parcel has an outgoing links to relationship to another resource provided by the GeoPortal of Bavaria. It also has an incoming depends on relationship with the digifarm you see here, which means that digifarm is dependent on this resource. The other incoming relationship is a links to relationship with a resource from the chair of geoinformatics. The important thing we see here is that for each related resource, its relevant organization is mentioned, and it is possible to click on each resource and see the resource in detail. Depending on the access level, all visible resources can be seen here. Unlike other catalogs, such as the one in Spatial Data Infrastructure, the SRADI catalog covers not only datasets and services, but also other types of resource information, such as devices, landscape objects, and so on. For example, here we have a resource registered with the name Hef Laura van Gateway at Weinerstefaneberg. On the Group tab, we always first see the main category, which in this case shows that this registry is for a device. For our specialized instance, we may also see the research stations or research themes categories. The research theme for this registry, for example, is of type technology. Here we have our metadata with a list of attributes such as the description, spatial extent, and some additional information like author, maintainer, and so on. We have the possibility to add some additional data here. For example, here is a user manual for this gateway, and we also have the possibility to preview this PDF right here. To register a resource in the catalog, the user should populate the corresponding metadata. We have two levels of metadata. The first is the general information about that resource, such as the title, description, location, and so on. And the second is the information related to specific data that belongs to that resource, such as an Excel file or PDF. And for each of these sort of data, a metadata should be populated. For each resource, the first or general level of metadata has several attributes. The two main attributes are the spatial extent, which defines the location or geometry of the resource, and the temporal attribute that defines in which time period the resource has been collected or carried out. Another important attribute is the groups, where the user defines to which group the resource belongs. As you might remember, we have three types of categories. The first is the main category, which is obligatory for each resource, and the other two are the research stations categories and the research themes categories. A key aspect of the metadata concerns access rights. The general metadata of each resource is either private, meaning that it is visible only to members of the organization that owns the resource, or it is public, in which case even users who are not registered can see the general metadata. Please note that each resource belongs to only one organization, who is also typically responsible for maintaining the resource. Each resource can have 0 to multiple data, and each of these data, such as this PDF here, would have their own level of accessibility. Even if the general metadata is made visible to the public, the visibility of each data can be independently restricted. In order to optimize the searchability of the catalog, in addition to the text search, we can also filter based on various parameters, such as the date of collection, the location, the owner, groups, tags, formats, and licenses. What sets our catalog apart from others is the way the groups are defined. The predefined resource types here add specific semantics to each resource registered in the catalog, and this improves the searchability and retrievability of that resource. In this example, we are interested in specific land parcels in one of our university's agriculture research stations. At the moment, the total number of resources in the catalog is 60. To narrow down the resources to those relevant to a specific research station, we go directly to groups. For each research station, there is one entry here. We choose the GeoNAST research station, and we see that for this station there are 48 resources. If we now look at groups again, we can see which types of resources exist for this specific research station. Recall the 9 elements of the main category: devices, landscape objects, animals, and so on. Here, for this specific research station, we can see these categories. We have here, for example, 29 datasets, 17 landscape objects, 2 projects, and 1 device. Now we would like to see what information is available for a certain spatial region. So, on the map we choose the area we want, which includes some landscape parcels and the main facilities of this research station. By doing this, we narrow down the number of resources to 13. Now let's go back to groups. We now have 10 landscape objects, 2 projects, 1 dataset, and 1 device. The organization section is also interesting. Here we see which stakeholders and organizations are active on this research station and region that we have selected. And we see that of the 13 resources, 10 of them belong to the TUM administration, 2 to the Hans-Eisenman Forum, or HEF, and 1 resource belongs to one of our members at HEF. Now, let's select the resources provided by HEF. If we look at the groups section, we see that one of these resources is a device and the other is a project. The functionalities that we introduced here and the ease of use of the tool helps to have better stakeholder engagement and more efficient planning and decision making in, for example, any geodesign process. For more information, please follow the links in the description of this video.